Hey, it's me, Miss Wesley. So happy to be here. One of my favorite parts of the day is talking trig with you. We're about to get into the trig packet. We're going to start on page 16 and work our way through. But for now, I got to be honest. I've just been sitting for the past couple minutes and marveling at the beauty that is the unit circle. The circle that has the equation x squared plus y squared equals 1, and it has a radius of 1, so that all the x values around this unit circle get to be the cosines of that angle, and all the y values get to be called the sine. We went through the unit circle in a previous lesson and we labeled up all the coordinates of the special angles that had maybe 30-degree reference angles, 45-degree reference angles, or 60-degree reference angles. Here's one of them. Here's a triangle that's constructed by dropping a perpendicular down at a 30-degree angle. Do you see those coordinates there? We found that because the sine of 30 degrees is a half, that's your y value. And because the cosine of 30 degrees is exactly square root of 3 over 2, that's going to be your x value there. Well, that's just like, let's go to quadrant 2. What angle has a reference angle of 30 degrees? 150. 150 is going to give you the same dimensions of this triangle, just with a negative x instead of a positive. Same thing with 7 pi over 6 and 11 pi over 6. We took that a little bit further. We went to 45-degree reference triangles, right? We've got a square root of 2 over 2 twice as your coordinates in quadrant 1. How about a 135? For 135 degrees, you have both those coordinates, and then that's the same for what, 225 and 315, whereas we could also go to a 60-degree reference angle and get these purple triangles that are all going to be the same size. Sines and cosines will switch SIGN sign as you go around. And I want to jump to this. It's a thing of beauty. I think I never would get a tattoo. But if I would get a tattoo, I think I would get this unit circle. Maybe just like right here on my forearm, just to like be able to look down and say, bam, what's the sine of 330? No problem. Let me look down, go to 330. The y coordinate's going to be the sine. Sine is always the y, negative a half. Most of this on this picture we're familiar with. All these degree measures we've been working with a good bit. We haven't worked with these guys, the expressions in terms of pi. That's coming. That's coming in a lesson or two. That's going to be the radian measures. But all these filled in coordinates around the unit circle are going to be helpful. Now, we've talked about how, I'm at the bottom of page 16 on the trig packet, we've talked about how you don't want to have to draw the entire circle every single time you answer a series of questions. So what I'm going to do first is, you have this little trig toolbox. Can you flip 2 pages over to some examples on page 18? We're going to start at the top here, cosecant of negative 225. But so that I don't have to draw the whole entire circle, can you just sketch quadrant 1 with me? So I'm going to just do my best for a 30 degree, a 45 degree, and a 60 degree reference angle. And I'm going to put the coordinates on here too. So you got to think sine and cosine. Everything's over 2, right? Maybe I'll just fill in the fractions with the 2's on the bottom. Over 2 over 2. What was it again? The sines start at 1 and they count up. So this y is a half. This one's going to be square root of 2 over 2. And the next one will count up to square root of 3 over 2. So 1/2 square root of 2 over 2, square root of 3 over 2. Can I have room for that there? Square root of 3 over 2. How about the x's? X's should do the opposite. The cosine of 30 degrees is square root of 3 over 2, then square root of 2, if it'll let me. And then 1 will be the very last one. So this one was, what am I missing here? Square root of 2. And this one was a 1, like that. The only ones I ever mix up are the 30 degree and the 60 degree, to be honest. The 45 degree is kind of its own animal. It's the only one that gives you an isosceles triangle when you drop a perpendicular down to the x-axis. So it's the only one that's going to have the same exact x and y value, square root of 2 over 2, square root of 2 over 2. Sometimes I mix up this 1/2 with the square root of 3 over 2, but think about this triangle that's formed. With 30 degrees, you're going out horizontally a lot farther than you're coming up. So put the bigger fraction first as the x and the smaller one as the y. And if I've already used up this set of coordinates for 30 degrees, I'll switch them for 60 degrees. Okay, so that was most of the work, and that should help with all these on page 18. Let's look at a couple of them together. Start with cosecant of 225. Did you check this one out? Think of a quadrant first. All right, negative 225. I got to start at 0. I have to go 225 degrees clockwise. So I'm going to go all the way around to quadrant 2. 225 degrees this way, right? Technically it's negative. Think of a reference angle, a theta prime, and that would be the same thing as doing 225 minus 180. Right? Take away 180, you get 45 degrees. This thing is going to equal the cosecant of 45 degrees, but maybe we need a negative sign out front, maybe we don't. Well, think about it. AS, sine and its reciprocal, cosecant, stay positive. So keep this trig function positive. Then look to what I just drew, or think of the cosecant of 45 degrees. I have to flip the sign or flip the y value. It'll just be square root of 2. That is the reciprocal of square root of 2 over 2. So we'll leave it at that. How about another a bunch of negatives, a series of negatives here. Let's look at 16. So negative 30 degrees, that's down in quadrant 4. You're going 30 degrees clockwise. That 30 degrees happens to be your reference angle, right? It's just the same as saying 330 there, right? That's the same as a negative 30-degree angle. Will equal the cotangent of 30 degrees. Should we put a negative sign on it? I think so, because you're in this quadrant ASTC, which does not stand for cotangent, only cosine and secant are positive there. Now the picture comes in handy if you want to use it, or if you want to use the table, that's fine too, but I'll use the picture, go to 30 degrees. Cotangent is a reciprocal of tangent, so it would be x over y. Let's go negative. The x coordinate I see from the picture is that fraction, and the y coordinate was this fraction. We can get rid of those 2's. And negative square root of 3, you're trying all these, no calculator, exact values for your solution. Let's move down to number 17. It says sine of negative 450. So my first order of business for this one is get a coterminal angle of a higher degree measure that's just more in my wheelhouse, from 0 to 360. If I add 360 once, I get myself up to negative 90. That's pretty good. If you want, you can add 360 a second time, thereby adding a 720, and you get 270 degrees as coterminal with that original angle. We know where that is, sine of 270. Quadrantal, don't really need this picture to help me with a quadrantal angle. Back when we were learning about those, we just use a unit circle where we labeled points. Say at 270, you'd be down at 0, negative 1. Same idea though, we can use the y value for the sine and say that final answer, exact value, is negative 1. You have to admit, this is a little bit fun. A little bit? Let's look at 18. Secant of negative 120. All these negative angles here. Negative 120, start at 0, go clockwise 120 degrees, and think of a reference angle, right? 180 minus 120 leaves you 60 left over. It's funny how the more you see these angle measures, like 120s come up a bunch, 210 we see a lot, you start to get more used to what the reference angle is going to be. So I'm going to relate this to some sort of secant of 60 degrees, but I'm cognizant that I might need a negative sign out front. So AST, yeah, secant's definitely going to be negative in quadrant 3. So I'll go back to my trusty picture. I'll think of the cosine of 60 and flip it. Cosine of 60 is your x value. You're not going out as far as you're coming up, so it's going to be a half. We want to flip it for its reciprocal secant to be oops, I put a half. Flip it, don't forget that part. How about negative 2? Does that look better? What's up next? Sine of negative 30, tangent negative 45. Got to pick some good ones. Let's skip down to sine of 600. Let's try 21 together. So sine of 600, let's pull the same trick we did in number 17. Can you subtract at least 1 360 from that? And then we'll see which quadrant this falls in. So 21 is sine of 600. That's going to be equivalent to the sine of 240. 240 we've seen, right? 240 is in quadrant 3. So this whole thing is 240. If I take away 180, my leftover is the reference angle. So you're thinking 60 degrees. Use the sine of 60 degrees. Be ready to put a negative sign out front. AST, right? Only tangents, reciprocal are positive there. Let's make that negative, and we'll leave that out front. So sine of 60, maybe I can do this without looking up to the top. The sine of 60, think of a 60-degree angle. You're coming up further than you're going out. That's going to be your square root of 3 over 2. So we'll go negative square root of 3 over 2, and you can check that with your unit circle. All these are good, right? All these are going to be good practice examples. I got to find something interesting enough for you guys. Well, we just did the sine of 600. Do you want to skip down to 27 and do the tangent of 600 right now while that angle's fresh in our minds? We can get it out of the way. So 600, Same idea, we can subtract a 360 to get tangent of 240. We already drew this picture. Quadrant 3, reference angle is going to be 60 degrees. But this time it's just the tangent instead of the sine. Well, you know for a 60-degree angle, you're coming, we said, up further than you're going out, so 1/2 comma square root of 3 over 2. And we put the sine over the cosine. So we'll go square root of 3 over 2 divided by 1/2. Now, did I miss a negative sign that was supposed to be here? Because we're not in quadrant 1, we're in quadrant 3, where it's AST. Oof, thank goodness. Tangent gets to be positive in this quadrant. So keep this positive, keep that positive, cancel the 2's, and we'll say square root of 3. All right, one for the road. I noticed there's one problem right underneath of this, 29. It's got a negative sign out front of the trig function. Is that going to affect things? Well, yeah, it's just going to be taking your answer and changing the sign of it. So let's still, 510, I see this a couple times on the page. Let's figure out something coterminal. Can you subtract 360 and see what we're working with? So we'll leave the negative sign that was in the original problem. We'll call this equivalent to the sine of 150, which is 510 minus 360. Where does 150 fall? So 150 is over here in quadrant 2. How much more would you need to get to 180? You've got a reference angle of 180 minus 150, so 30 degrees. So this equals negative the sine of 30 degrees, and no more need for switching the SIGN. You're in the AS quadrant where sine is positive. So if somebody wants the negative sine of an angle that's in quadrant 2, well, that's where this negative sign comes from. It's going to make your answer negative. So if we know the sine of 30 is 1/2, let's say the negative sine of 30 would be negative 1/2. All right, keep on practicing, get used to these values. Enjoy the rest of your day.